Well, good afternoon, folks, and welcome to the PhD application process, Biomedical Scientist PhD programs, and how to prepare and apply. Thank you very much to our panelists for attending today. We should be in for some insightful conversation. This webinar will describe the preparation required for students to be competitive applicants to a PhD program and the application process. Participants will learn how PhD programs prepare students to become experts in a particular area of science and to pursue careers in many different areas of biomedical research. Speakers will discuss the major components, personal statement, letter of recommendation, etc., and the timeline for a successful PhD application. The panel of biomedical graduate program deans will address necessary undergraduate preparation and share practical strategies. The PhD Outreach Committee of the Association of American Medical Colleges, the AAMC, have organized this webinar in collaboration with NRMN. Panelists do not discuss individual programs, but discuss common features of these programs. The workshop includes time for a Q&A. Upon completion of the webinar, students and mentors will have a working knowledge of how students can enhance their undergraduate preparation. They will also understand the application process and the various elements of competitive applications for graduate programs leading to the biomedical PhD. Without further ado, Drs. Nancy Schwartz, Nancy Street, and Victoria Friedman. Thank you very much for taking the time today, and welcome.
Hello, everyone, and welcome to the webinar on the PhD application process. My name is Victoria Friedman, and I will be working together with my colleagues, Dr. Nancy Schwartz and Dr. Nancy Street, to take you through everything that you need to know about applying to PhD programs. Next slide, please. During this webinar, you will probably have lots of questions. Please type your questions into the question box in the webinar panel. And at the end of the presentation, we'll be sure to answer as many questions as we can. So let's start with a quick overview of biomedical research. What exactly is biomedical research? Well, it is finding out how cells and organisms work in health and disease. It is mostly done in the laboratory, but not always, since many studies are also done in populations, in clinical groups, or on a systems level. So you'll be using lots of desktops. It can be hard work, but the real secret and the reason that we all love it is that it is lots of fun. Next slide, please. We get a lot of questions about what exactly is biomedical research. And here you will see that it is really a combination of all the sciences that you know: physical sciences, basic biological sciences, quantitative sciences, disease-specific research, patient-oriented research, all carried out by scientists who are using the power of research to improve human health. Next slide, please. Who can become a biomedical scientist, and how does that happen? That's some of what we are going to explore today. Basically, the starting point is anyone with a STEM education. And by that, of course, we mean science, technology, engineering, mathematics. And you will see some examples of STEM backgrounds on this slide. Next slide, please. So this is a good time to take a step back and ask yourself, are you really interested in human biology and disease? Are you a very curious person? You want to know how and why things work the way they do? Do you think creatively in the way that you examine things and do things? Do you love science? And most importantly, do you have the persistence to see a project from very small beginnings to great discoveries? If so, you are really starting to think like a biomedical scientist. Next slide, please. So where are biomedical scientists trained? They are trained in PhD programs, which you will find in university graduate schools and schools of engineering, as well as in medical schools throughout the United States. And now I have the honor of introducing my colleague, Dr. Nancy Schwartz, who will tell us some important details about the qualities of a scientist, how to prepare for a PhD program, and what we need to keep in mind as we move toward the PhD. Nancy.
Good afternoon, everyone. I'm going to focus for most of this time on the admissions process, because for those of you who are just either thinking about going to graduate school or actually preparing for graduate school, this is the first step. So the first thing is you ought to ask yourself, what are PhD admission committees looking for? Definitely a student with a strong science background and who understands what research are the two primary things, and we will spend a little more time talking about those. As well, there are some personal qualities that are very important, being objective, honest, able to communicate. That is extremely important, both verbally and in writing. An ability to integrate and process information, and again, increasingly, an aptitude for working with others, either in a team or in a group setting. Next slide. Additionally, you have to have a reasonably good academic record. This is something we can talk about more in the question and answer period, including your graduate, your GPA over time, and the national exam, the GRE scores, which many schools these days are de-emphasized somewhat. To continue in a PhD program, you do have to have a STEM undergraduate major, and certainly most programs would prefer to see advanced courses in the sciences as well, and a substantial research experience. Next slide. Now, another question that's often asked at the very beginning is, how am I going to pay for this next degree? Especially for those of you who had to worry about how you paid for your undergraduate degree. Well, the surprise here is that since the 1950s, with partnerships between academic institutions and the federal government, if you get a PhD in the biomedical sciences, your way is paid for that degree. Most often you will receive a stipend, which is geared to the cost of living in the area in which you are, and your tuition is covered. You get some benefits. These may vary from schools, but most schools give at least health insurance. Other kinds of benefits could be relocation fees, help with living expenses in very high cost areas, things like that. Next. Now, it's very important to realize at the beginning that whatever you do after you get your undergraduate degree, you do not have to immediately transition into the next stage of your higher education. You know, whether you're going to professional school or graduate school or whatever. And for graduate school, there are many things that you can do for a short period of time, usually only 1 to 2 years, between getting your undergraduate degree and moving on to graduate school. Some of those would be doing what we call a post-bac. One of the most popular places is NIH, which has a wonderful post-bac program. It's very large, a couple thousand students. You can just get some further research training if you think you have some deficits in this area. You can do a master's degree. Certain areas, not all, give these, but there are masters out there. You can get other kinds of on-the-job training, especially if you're thinking of a long-term career in the private sector. There are certain pharmaceutical biotech companies that would give you jobs at the bachelor's level, and then you go back to graduate school. And, if your record is not as good as you think it needs to be or that you want it to be, you can take some graduate courses, either while you're doing one of these other things like getting research training or so on, or just on your own. Or you can do one of, I don't know, there's about 25 or 30 prep programs. These are also post-bac programs around the country supported by NIH, but they're in institutions instead of at the NIH in Washington. Reasons for doing these kinds of things is either you might not have a record that you think is competitive and you want to enhance it. You have not had sufficient research experience, or you simply don't know exactly what you want to do and you want to take some time off to kind of figure things out, let mature a little bit, and be able to make more informed decisions. Next slide. So before you apply to any graduate program, and this is how you investigate the programs, you really have to do some investigation before. So reading scientific literature, attending conferences and webinars like this, talking to people, anybody you meet, graduate students, TAs, friends of yours that have moved on to do these things, your mentors, other faculty. You have to get that research experience, and you have to understand the application process and especially the deadlines that go along with it. Next slide. So, question that's always asked is, how much research do I need and what kind of research do I need? What is a substantive research experience? So having research experience during your undergraduate years usually happens in one of two ways. You do it during the summer when you have breaks, and students always ask, should I stay in the same lab for more than one summer, or should I change and go to multiple different labs? There is no right answer to this. It's whatever is right for you. If you find a lab that you're really happy with, you like the work, you're making progress, going back for a second summer might help you get your name on a paper, then that might be the right thing to do. If you're undecided about the kind of research that you want to do and you need to explore and have different opportunities, then you should do a different research project every summer. We go back to slide, yes. Another way is doing research during your undergraduate years, whether it could be with the outcome of having a senior thesis, culminate in that, or just doing research on your campus during. This is another way to get. And the reasons that you do this is so that you can then convince the individuals that are going to be deciding about your moving forward in your career is, are you familiar with the idea of testing a hypothesis? Do you understand the implications of research projects? And can you articulate what you did? And maybe we can talk a little bit more about the really way that you do that that is convincing. Next slide. So, most important thing is applying to graduate school is not something that you can just sit down and do in a short period of time. As you see here, this kind of maps out your life for the year before you actually go off to graduate school. And it takes you about that amount of time, almost a full year. So for those of you that might be thinking of going to graduate school in fall of 2018, now is the time to start thinking about these things and preparing yourself. First thing to do is identify the schools that you want to apply to. As was mentioned earlier, there's over 600 graduate programs of all different types, so you have to do some investigation. We can talk a little bit more about that. You can start the applications. They're all online, so you can start filling in the blanks, those kind of things, and then work on them go back and forth and work on them. Obviously, those with the earliest submission dates are the ones that you would work on sooner rather than later. You have to sign up and take the GREs, and obviously most people would recommend that you do some kind of preparation for that. You have to get letters of recommendation, and if you are, say, doing a postbac or doing something and you have been out of school for a year or so and you want to use some recommenders that were from your undergraduate days, obviously that is something that you have to do with a good letter of explanation about what you want to do and why you're doing it and what you have done to prepare yourself to do it. Deadlines for applications now, most of them are December 1st, some are as early as November 15th, and then there are some that go up to January 1st. So that is something that you will stage them depending on when the submission date is. You have to get your transcripts from your undergraduate and any other coursework that you have done. You might have to then re-request letters. So that's the first phase, getting the application and all the application material in. Then the second phase is being invited for interviews, going to visit the schools, spending a day or two with faculty, graduate students, all those, and helping in that decision to know whether it's the right thing or not. Hopefully you will receive more than one decision, and then you will have the opportunity to decide and pick and choose what you want. Final decisions are due by April 15th, and then over the summer, and some programs actually do start earlier in the summer. Next slide. So what should you look for in a graduate program? Well, of those 600 plus graduate programs, many of them are organized very differently. Some of them are very discipline specific, and if you know exactly what you want to do, then you would be applying to those kind of programs. If you think you like, microbiology and immunology and things like that, you might look for something that is more of a interdisciplinary or umbrella program that would give you the opportunity to explore different research projects, take more than the normal amount of courses or something. You also look for any kind of unique training opportunities, specific instrumentation, things like that, support mechanisms, both academically and for other skill kind of things. Very important, you're obviously going to be looking, because you're going to be spending the majority of your time doing a research project, so you'll be looking for faculty and what do they do. Be looking for a nice environment to be in, so you would be looking for the group of happy graduate students in the program you hope to join, and you should check out what do the graduates do. Next. So other things that you could consider these days, it is extremely important to really think about getting other skills beyond just knowing how to do research and doing a research project. So you would look for programs that also have the opportunity to allow you to teach and get that kind of experience, to do writing and so on, and if necessary, programs that would have support mechanisms like counseling and tutoring. Quality of life in the area that your school is. Obviously, if you're married and have a family, you're might be looking for a different kind of experience than if you don't have those things. Other kinds of cultural, social support, and so on. Geographic area is often very important to certain people, either to be, weather, depending on the weather, or closer to family, things like that. Next. So how you can get more information about the programs? Well, certainly any of these things that you do along the way, like participating in summer undergraduate programs, this gives you the opportunity to investigate that campus that you're on, that school that you're at. You can do this also by informal arrangements, just going and visiting. doing research at your own institution and learning about different kinds of research, meeting all kinds of people. Every time you have any one of these opportunities, talk to the students. Why did they do what they do? Why did they go to a particular school? Why are they interested in the areas they are? Same thing with postdocs and with the faculty in the laboratories and so on, that you have these opportunities in. And then again, on your own campus, or if you're a visiting scientist someplace else, go to lectures, seminars, and conferences, and this will give you a very broad perspective and a good understanding of what kinds of opportunities there are out there. So now I'll move on and let my colleague, Dr. Nancy Street, discuss the next set of things for you.
All right, well, welcome everyone. And in this very last section of our talk today, we're going to focus on the application process and the interview process. I should mention that in October, there's going to be another NRMN webinar that is solely dedicated to answering questions about creating a great personal statement. And then in December, there'll be another NMRN webinar that will focus on how to prepare yourself for the interviews. So next slide, please. So what do you need to apply to a PhD program? As you notice on the timeline that Dr. Schwartz presented to you, if you are planning to be in graduate school in August of 2018, August is the month that you should begin the application process. And so the very first part of any application will be going to an institution that you've decided to apply to and finding their own application form. Every institution has its own form and you'll have to fill that out, much like creating an online order for something. You will go to that application form, you'll begin filling it out with a username and password. You'll look at the information that they're requiring, how to upload your transcripts, all those types of things. And you should know that you are the owner of that application. And it's also your responsibility to bring it all the way through to completion. So you should perhaps keep a spreadsheet of every school that you're applying to and indicate on that spreadsheet, have letters been submitted, is my transcript there, what aspects are missing, and then log back on occasionally to make sure that all items have arrived. So once you've started the application form, there really are 4 other components. There's your personal statement, which we'll talk about in great detail in just a minute. There are letters of recommendation. There are your transcripts, and here you should know that you will be asked for transcripts for every undergraduate institution that you've attended, as well as any transcript you might have from participating in a post-bac program. And then if you've completed a master's, they will want to see those transcripts as well. And finally, the other component that almost every school will ask for is a copy of your GRE examination. And you should, as mentioned, plan to take that in advance. So definitely by September, you should have taken the GRE so that there is time for them to analyze your writing section of the GRE exam and get the scores back to you. The GRE score is being de-emphasized amongst admissions committees across the country, but with the exception of one program, to my knowledge, every school still requires that as part of your graduate school application. Next slide, please. So really the core of your application is going to be the description that you give of the research experiences that you have participated in. And you've heard a little bit about what is a sufficient research experience. Ultimately, admissions committees know that you've had sufficient research experience when you've done enough projects or worked on one project long enough that you are familiar with the idea of testing a hypothesis. And not only that, when you talk about your research, people will want to be well aware that you understand the implications of your research project. So they want to know that you understand the why, behind the research project that you've been involved in, not just the technical aspects. Of course, it's important to become technically proficient in the science that you do, but we're looking for people who are as engaged in thinking about the science as they are in doing the science. And then it's very important in your application that you can communicate your research experiences and the contribution that that research will make to the field that you are studying. Next slide, please. So here's some guidance on the personal statement. The most important thing is make sure that your statement is a reflection of you. This is your one opportunity to speak to the admissions committee in your own voice so that they can begin to form a picture of you in their mind. So there's no formulaic statement that should be included. You don't need to put in any catchy opening like a quote from the Bible or Shakespeare. What you really want to do is interest the people who are reading your admission statement in reading more. This is your opportunity to stand out because of the things that have driven you to science, the things that you're passionate about in science, and the description of the research that you've been involved with. So think about what makes you a unique candidate. Write your story as if it is a story. People will read it, and the more of a story flow that it has to it, the more engaged they will become by it. And mention things like, what interested you in science to begin with? And why are you choosing this path in the program that you're applying for? And of course, we always want to know if you have won fellowships, if you've won awards, if you've presented your science, and then non-scientific activities as well, if you can connect them to your scientific story. And it's also very illuminating when students who are applying discuss their mentors and the experiences that they've had that contribute to their scientific journey up to this point in time. Next slide, please. Now, be very careful to also clearly describe your research experiences. And often, people who are applying discuss a great deal about the technical contributions to the project. Know that you should also discuss your intellectual contributions to the project. Talk about what your role was on the team. And you can talk about what techniques you mastered, although this should not take up the bulk of your description of your research experiences. And then here again, mention publications, presentations, awards that you did related to the research experience that you're discussing. And make sure that if other people presented your work, that you mention that publication or discussion of your research as well. Let's circle back one more time to the point to why are you pursuing a PhD? That is an important part of the personal statement. Admissions committees are interested in knowing what your future career goals are and what your motivation to pursue the degree is. And if you simply say, I love science, that is a great thing to know about you as an applicant, but we would like to hear specific examples of why you love science. And finally, in your personal statement, it is very illuminating when you are applying to a particular institution to explain why that institution is one that you've chosen to apply to. So you could talk about the strength of the faculty, you could talk about areas of science that are prominent on that campus, and you'll want to make sure you do this for each institution that you are applying for, and then be very careful that you send the right application to the right institution. It probably goes without saying, but as you write your personal statement, be sure that you give many other people opportunities to review and edit it for you. Run spell check, proofread, proofread, proofread. As I said, your personal statement is our ability to begin to see you as a person, and you do not want to leave a bad impression for misspelled words in your application. Next slide. Okay, now let's talk about another very important part of the application, and that is letters of recommendation. You should always choose professional references over social references. And what I mean here is the very best letters come from any research mentor that you have had. These are the absolute most important letters of recommendation because admissions committees are made up of research scientists, and they have most in common with research mentors, and they will be able to understand how they assess you and rank you best in letters from research mentors. Academic advisors who know your career goals and the many steps that you've taken in your path to a PhD can also be good letters of recommendation. Professors in classes in which you excelled, those can be good letters of recommendation, but make sure that they can write more than this student made an A in my class. Because if that's all they can tell us, we could look that up on your transcript. So the burden is really on you to build relationships with people who have mentored you in a scientific way, and then maintain those relationships as you move through your undergraduate career. It's very important to note that a poor reference letter is a bad reference letter, and it is your right to ask someone you're considering write a letter of recommendation, will you write me a strong letter of recommendation? This is very important to your application, and so you want to have the best letters of recommendation possible. Next slide. A couple more things about letters of recommendation. Once someone has agreed to write you a strong letter of recommendation, make sure that you give them your CV, the latest draft of your personal statement, copies of your transcripts, like I said, your personal essay, even if it's a draft, and then a sort of paragraph by paragraph summary of research experiences that you may have done with different faculty. And those could be in your personal essay, but if they're not, make sure you provide those. And then you already will have given them an opportunity to say no to writing you a letter. And this is important. If someone does not seem excited about writing you a letter, you do not want that person writing you a letter. So let that person decline your opportunity to write you a letter and find someone else. If possible, if you're in the same city, meet with your letter of recommender writers and talk to them about the schools that you're applying to and why each one would be a good fit for you. And just emphasize to them as often as you can that you need a strong, detailed, supportive letter. Remember that scientists are very busy, so it's important that you give them time. If you start the application process in August, you should have all of your letter writers lined up by mid-September at the latest. And then you should alert them when you apply to different schools to let them know that they will be receiving an email asking for them to submit the letters. As I mentioned, scientists are busy, and so you may notice as you track the completion of your applications at different schools that occasionally a letter of recommendation is missing, and you should check that and then very politely reach out to the person who has not yet submitted their letter and ask them to submit it. Of course, giving them as much time as possible to do that. Next slide, please. Okay, so let's say you've completed the application, you've hit the submit button on them, and schools begin to contact you about coming on an interview. And so as I mentioned, there'll be another talk in December about preparing for the interview. Interviews run from January through March in the winter and spring after you apply. And preparing for the interview is an art in and of itself. So the first thing you should know is the audience that you will be meeting with. So you will be talking to faculty and graduate students and administrators at the schools that you visit. And each time you head to an interview in advance, you should refresh your memory about the program and come prepared. So if you have indicated an interest in speaking with specific faculty members, you should refresh your mind on the work that they're doing. If you are not allowed to pick who you'll meet with, then you should get a schedule from that school in advance of your visit and read a bit about what those scientists are doing. So hopefully you will have some input and get to meet with some faculty that you're interested in. The other thing you should know is what questions you want to ask about that program and the outcomes data for their past trainees so that you can assess, will those outcomes fit with the direction I'm going in? Is the way they run their program compatible with the type of program that I'm looking for? Every interview weekend is 50% the school learning about you and 50% about you learning about the school. So be ready to make your case. You should expect to be asked about every research experience that you have been involved with, and you should know what you did in the research experience and be prepared not only to discuss what you did, but where that research can go in the future, okay? You should also come with some idea about what you might like to do in the future, and then be able to say why you applied to that particular school. And here they're looking for more specific things versus like, I've always heard of this school and I thought it'd be a great place to get a degree from. Next slide, please. Some more things you should know is reread your application in its entirety. By the time you go to interviews, it will have been several months since you submitted them. You probably applied to many schools, so break out that specific application for that specific school. See what you highlighted in the personal statement. See which faculty you requested to meet with. And then again, be prepared to ask questions about how that school operates, all the way from when it starts in the fall, how many rotations you have to do, those types of things, to the outcomes of their trainees. On the actual interview weekend, be sure that you dress professionally in a business casual manner. That means more than jeans and a t-shirt, but probably less than a three-piece suit. So you can get some hints from the correspondence you get from the school. If you have questions, be sure to ask. Your communication style should be businesslike but friendly. And you should be relaxed, but remember, from the moment you arrive at a school until the moment you leave, you are being evaluated by the students and the faculty there. And they are looking at how you would fit into their group and your potential to become an independent scientist in the future. So that wraps up, wait, not quite yet, one more slide, please. So our hope is that you will apply, you'll have many interviews, you'll get offers, and you'll be heading to a PhD program in whatever timeline fits your particular level of education. So what can you expect in a PhD program? Well, year 1 and 2 are, have a great deal of time in the classroom completing the coursework that will provide the foundation you need to complete your PhD. You also will do rotations so that you can select a lab that is the best fit for you. You'll select a mentor, and you will take your qualifying exam. From year 3 on, the primary focus of your time will be on completing the research that will make up your dissertation. You will write your thesis and defend it. In those same years, you'll be learning more and more how to improve your communication skills through writing papers, grants, presenting your research on your campus and off your campus, and then also spending a great deal of time assessing and reassessing what it is you'd like to do with your PhD. And then starts the next phase of your adventure. So now I'll turn it back over to Dr. Friedman.
Well, as you can see, the PhD application process requires preparation and planning. We have gone over many details about the timeline and the process of identifying schools and programs, the personal statement, which is a real challenge for everyone, the letters of recommendation, and the interview. This webinar will be available on the National Research Mentoring Network website shortly, or you can subscribe to the NRMN YouTube channel and go over this webinar again and again as you prepare your applications. Now, I see that we have had a lot of questions, and I want to get to these as soon as possible. Please continue to type in your questions into the Q&A box at the bottom of your screen, and we'll answer as many as we can before our time expires. You can also find a lot more information at these websites listed here, and you can get a lot more information from discussing your plans and your ideas with knowledgeable people, directors and mentors of summer programs and post-bac programs, professors and lab heads, other graduate students and postdoctoral trainees, the career advising offices at your undergraduate institutions, and of course, PhD program directors and administrators and deans. Just like us, we all want to help. So be sure to communicate with us. Now let's start with the questions. So the first question is from a student who asks, if I am an international student, is the PhD still paid for? So let's start with that question. Dr. Street, do you have an answer for this?
Yes. Many graduate programs do accept international students, and they also receive a stipend from the day that they start until the day they graduate at the same level as U.S. students, as long as they continue to make progress towards completion of their PhD.
Terrific. Another question, is there a big difference between graduate programs in medical schools and graduate programs that are not in medical schools? Dr. Schwartz?
In some ways there are differences, in some ways there aren't. And often the first thing to look at is what is the discipline that you're interested in? And is there any reason why you would want to do research that might be either, disease-oriented or translational research, which is very popular these days and so on? That would be one kind of thing. But for many of the disciplines, like biochemistry, you're going to find that in a medical school, you're going to find that in an arts and science kind of thing. In a medical school graduate program, you probably will not find ecology, evolution, or some of those kinds of things. So, but there really is no difference in either the quality of the education or the opportunity.
Great. So we also have a question about recommendations, and this is a question that we hear all the time. This student is saying, I didn't work directly with the PI of the lab. Is it acceptable to get a recommendation from the postdoc or graduate student with whom I work? Dr. Street?
That is an excellent question. And the answer is the letter should come from the PI of the lab. That person's status will bring much more credibility to the letter, and a letter from a postdoc or a graduate student would be valued much less simply because postdocs and graduate students have only trained perhaps one or two students, and they don't have the expertise that we feel necessary to weigh in appropriately. So what many PIs do, if a summer student, for example, asks for a letter and they recognize I didn't really know that much, they will call in the postdoc or the graduate student to give input or perhaps even co-write the letter with them. They are very interested in helping you, and so they will do what they need to make sure that it's a good letter.
Excellent, thank you.
That's exactly the way it works best. And you can make that suggestion that postdoc or senior graduate student or whoever sort of mentored you at the bench collaborate with the PI of the lab to write the letter together.
Good. We have another question about the length of the personal statement. Is there a standard length? Is there a guideline for how long the personal statement should be? Dr. Schwartz? I see you smiling at this.
600 graduate programs, there are 600 different applications. One of the reasons why you have to start them early and look at them all the way through. Some of them, they ask for a personal statement, which is a holistic thing about how you came into science, experience, how you're making your decisions. And others, they will call focus more on your research experiences. And they might general kinds of things about yourself. Some applications have a word limit or a space limit. It could be a 600 word thing, or some of them
questions about the MS degrees from our listeners. So I'm just going to read them and then we can talk about them. So first of all, does having a master's in the biological sciences cut down on the number of years it takes to complete your PhD? Should you have a master's before doing a PhD? And what would you say is the biggest difference between getting a master's and then doing a PhD? So let's start with Dr. Street. Can you explain a little about the master's degree and the PhD?
Yes, so a master's degree is typically all focused on classwork and a small or none at all research. And so that's one of the major differences between a master's and a PhD degree. Even if the master's has research to it, it's a smaller project. And often students will earn a master's degree if they feel like they need more academic preparation. And so in our typical incoming class, less than 20% have master's degrees, and more than 80% come directly from an undergraduate program, although they may have stopped and done a post-bac or worked for a year or two.
Okay. That sounds good. If you have additional questions about the MS degrees, please be sure to put them into the Q&A box at the bottom of your screen. So another student is asking about the application fees and the cost to apply to different PhD programs. So I will answer that. As Dr. Schwartz indicated to you, there are hundreds of graduate programs, and yes, unfortunately, almost each one of those charges a fee. Some do not, but for students who are participants in groups such as NRMN or SACNAS or ABR-CMS, these application fees are often waived. So the best thing to do is, as soon as you see that a PhD application has a fee, the best thing to do is to write to the person where it says contact us with questions and ask if you can obtain a fee waiver. And in that way, you'll find that you are not paying for most of the PhD applications. So I hope that will be helpful to you. The next question we have is about maintaining a relationship with the summer research mentors. And we did highlight that in the slide and the importance of doing that. Dr. Schwartz, could you answer, how do you maintain that relationship?
Yes, that is important, especially if it was a good experience, one where you learned something and you had good relationships with the PI and with the other people in the lab. And you might want to use that individual for a referee in the future. So sometimes when students leave a lab, at that point, they will tell the lab head about their future plans and ask them at that time to sort of either take some notes or actually even write a draft of a letter about that person and keep it on file. Alternatively, as time progresses, I mean, frequently we get emails at holiday time from previous summer students saying, "Hi, how's it going? I'm having a great year. I'm applying to graduate school next year, but I'm still interested in using." So there are ways that you can keep in touch even though time passes. If you have not kept it, but you do want to go back to a prior faculty member that you did a summer with 2 years or 3 years, you really have to write a very detailed message back to them, telling them, "Hi, this is Joe. Hope you remember me from 2 years ago. I was in your lab. I worked on this, this, and this. I'm now, I finished my bachelor's degree. I'm now doing a year of post-bac and I'll be applying to graduate school. And I'd like to use you for a reference. Here's what I have done in those ensuing 2 years. Here's what I want to do in the future." Give them information so not only can they write something about what they may or may not remember about you in their lab, but that they can actually sort of fill in a little bit of how you are working towards your final goals.
Great, thank you. So I think we have time for one or two more questions. So one student asks, if I have a 2 or 3 year gap after the bachelor's degree, is that negative in my PhD application? How is that viewed by the admissions committee? Dr. Street?
That's a great question. And really, if someone asked me that question in person, the first thing I would ask them is, what have you done during those 2 to 3 years? If you have done something that kept you in the science environment, working in a lab, working in a company, staying involved in hypothesis-driven research, then I would say you should have zero concerns about that having a negative impact on your application. If you've done something that's been away from science, then you will have to work very hard in your essay to explain why you went away from science, why you're coming back to science, and how your previous foundation will allow you to be successful in a PhD program this coming fall.
Thank you. And for our last question, several students have asked about a magic number. Is there a magic number of graduate schools that we should apply to in order to make sure that we can start a PhD program in 2018? Dr. Schwartz, I see you smiling, so perhaps you can tell us this magic number.
Yeah, I don't think there's a magic number. Like applying to anything, you kind of have your reach schools, those that are your dream places. Then you have ones that you would be very happy with and would meet all of your expectations. And then you have a couple of backup schools. For PhDs, I think the average is maybe 5 to 7. And my colleagues can shake their heads if they're in agreement with that. Certainly, if you're more interested in professional schools like medical schools, it's more like 10 to 12. But usually it's somewhat less for the graduate school.
Yeah. Dr. Street, do you have a magic number?
I usually say 6 to 8, but I agree totally with Dr. Schwartz about having the dream schools, the schools where your numbers look just like the students that they have accepted in years past, and then I call them the safety schools.
Yeah, and I would agree. We usually say 6 to 8. More is usually better because you can always turn down the interviews if you have been accepted to the school of your choice. So I think 8 is a good number to aim for. And with that, I think we're going to wrap up. I again want to remind our audience that this webinar will be available on the NRMN website and also by subscription to the NRMN YouTube network. We hope that we have been able to give you a lot of information and answer questions about the PhD application process. And we hope you'll join us for detailed discussions in October about the personal statement, when we will go over every part of it in great detail. And then in December, when we will have a webinar on how to prepare for the best interview. So thank you again, and we will see you the next time.
Thank you again, everyone. Have a wonderful day.